In this video, we're going to discuss the differences between queryable and enumerable. And more specifically, when we're dealing with enumerable, we'll actually force it with a to-list. Now, what are the differences? Well, queryable, when working on that type of object, actually only builds queries for the database that will eventually become enumerable, or let's say we enumerate within a where clause with a for each, or we actually choose to list or looping through with a for each will query the data just in time for it to be used in memory in the application. Now, why is this important? Well, if you build your application wrong, there can be some circumstances where you're actually querying the database too often, and whenever you're doing that, you're affecting performance. Now, for small amounts of data, this is fine to a certain extent, but whenever you're working with large subsets of records, for instance, transaction data for financial information, or examples would be customer databases with multiple entries, then at that point you need to optimize how your queries are executed within your application. So I'll show you this with an example. Afterwards, we'll discuss what are the optimizations that we can do and what are the steps to actually view the queries that are being executed within LINQ so that we can optimize our database or optimize our queries, all depending, so that our execution is done in the least amount of time possible. So first off, I'll show you an example of the differences between queryable and enumerable. So I have a program here that I just built, which creates a context for a database, and in this case it's my testDB database. As you can see here, I have my testDB. I have one table called customers, and in my customers, if I refresh this, I have a column name ID for the primary key, and customer name also for the name of the customer. Now, I won't get into the details of this table, but this is a simple table. As you can see here, I queried my table, and for now I just have one record called Johnny B. Good. And you know what? I'm gonna actually add another record called Johnny Not Good. I'll show you why I'm doing that next. So I'll close this. If I execute this, you see here I have Johnny Be Good, Johnny Not Good. Now, first things first, I'm just going to lower the screen here. On my left hand side, what I have are the different transactions that are being executed on my SQL server. Don't look at this here for now. Just focus on what's going to happen next. So if I write some code here, let's say I click on DB, customers, and I put a where clause, and I put here C for customers, C customer name, contains be good. And here put keep it here. Put DB customers. Actually, I'm going to put here a var value, var be good equals this. Put a for each be var be in be good. Actually, I'm going to call it C for C and be good for now. And I'll put a console write line. Here. This, just put name, C dot customer name. Here. So I have my be good here, and I'm putting a write line. So what's the expected behavior here? Well, if I execute this, you'll see that on this line here, you see what's being returned is a IQueryable of model customer. And afterwards, I'm looping inside the be good object, and I'm writing the customer name. Now, what's going to happen in my left-hand screen? Well, this line here will not be executed on the database, and this line here will be executed in the database. So let's try it. So start. You see here I have my breakpoint here. If you look on the left hand screen, I don't have any transactions, and once I loop inside the be good, you see here I have my transaction. So if I click on F10, right line, if I put my customer name, see here, name, Johnny Be Good. I stop this. Now you see here, I executed on the database, I queried on the database when I went inside my for each statement. So what happens if I put here to list, for instance, to list? Well, what's going to happen is if I execute this here, you see here already before I went into my for each, it executed. Now, in this example, it would be like, it's not too bad because technically should not be executed twice. And as expected, it doesn't execute it twice. So that's fine. So I'll stop this. Let's say I want to put var not good equals db customers where c customer name contains, let's say here, not good. And here also I put to list. And let's say I want to union both of those lists together. Well, I can do this by this var u, let's call it union. Let's put be good union not good here. And instead of looping through be good, I'm going to loop through union. Now, this would combine both not good and be good together. Now this is just a simple example, but what this is going to do, it's going to start by executing on the first where clause with be good, then it's going to execute again on the database not good, and afterwards it's going to union in memory both be good and not good. Now, with small subsets of data, this is not the end of the world. But with large amounts of data, you're actually running two separate transactions, and depending on the situation, this can affect performance greatly. So if you see here, if I execute my console app, I put the breakpoint here. You see here, first one, be good, not good. It's being executed, so I have my two queries here. And union, as expected, does not execute. Console write line. If I look at my console app, Johnny be good, Johnny not good. Close this. Okay. So in this example, you'd be like, okay, this is not the end of the world. We're actually querying both. But whenever we're building on top of a query, let's say we're reordering, we're combining, we're combining different tables together, or we're filtering on multiple levels, then sometimes it's better to let the database take care of that. Whereas the code should only make sure that you execute one query at the end and it executes that on the server. So how can we do this? Well, the simplest way is to remove the toList. So let's remove toList here. So what's going to happen is, since it's vars, so I don't have to type my different values, union becomes an IQueryable. And you'll see that even in union, we don't combine, and it's only going to be executed when we're going to access the for each. So if I start the console app and I click on this, step through, see here I don't have any transactions. Even my union does not have transactions. And then afterwards, it builds the union from the LINQ query. And if I do this, see here one twice, continue, and you can see here, if I bring my console app here, Johnny be good, Johnny not good. It's a bit small. I put this here bigger, Johnny be good, Johnny not good. If I close this here, so what's my query here? So I click here, you see here my query, it's a bit small, so I'm going to copy it. Sorry, just got some transactions. I'm going to copy this, and I'm going to go in SQL Management Server. I'll create a new query. I'm going to copy this, and this is the query. As you can see, I can execute it. See here, returns Johnny be good, Johnny not good, column 1, column 2. That's called C1, C2, but same thing. Now, you'd be like, okay, this is my query. Fine, let's stop there. Actually, there's one more step whenever you're looking at a query executed here, which is the execution plan. So if you look at your SQL Management Server console, you see here you have something called Display Estimated Execution Plan. So you click on that, And you see here that you have a clustered index scan. So clustered index scan is it's scanning completely the table, and it's taking more time than it should. So for large amounts of data, this is not a good way of looking up information. What can we do here? Well, I know for a fact that I haven't put a an index on my table. So what I can do here is I can go inside my customer name here. I'll go in design and look at my index keys. I'm going to add an index. I'm going to put it on customer name. Okay. And let's put it unique. Save that. If I go back in my execution plan estimator, you see here I had a clustered index scan, which is clustered. Now, if I remove that, you see here, non-clustered, and now it's an index scan. Simply change how your index are being built. You can greatly improve performance on your database. So I hope this helps. So remember, Queryable for querying the database, for building the query, and toList and Enumerable actually queries the data on the database. And also look at your execution plan whenever you analyze what's being executed by LINQ-SQL, and look at your execution plan. Make sure you don't have table scans, full table scans. Ideally, you want an index seek, which goes a lot quicker, or an index scan. As long as you're hitting an index, those are the best scenarios. So I hope this helps, and happy coding.